Solve the following differential equation by using integrating factors. So how do we do that? Well, here's the steps from the notes. Step one, get dy dx alone or y prime, whatever. Then the y term, then the other stuff. So, okay. So step one. So I'm going to need to grab that y and bring it over. So we got y prime minus y and 4x squared. There we go. Okay. And step two. Find the integrating factor. Mu of x is e to the integral p of x dx, whereas p of x is whatever's next to y there. So I think, oh, okay. So I gotta look at what's next to y. What's next to y? Minus 1. That's my p of x. So then my integrating factor is e to the integral p of x dx, which is e to the integral. What's p of x? It is minus 1 dx. So what's that? That's e to the minus x, isn't it? Because the integral of minus 1 is minus x. In other words, the derivative of minus x will go back to minus 1. So there's my integrating factor. That's step two. Okay, and then step three, multiply the differential equation by that integrating factor, all three terms. Okay, so step three. So I'm going to bring down the differential equation y prime minus 1y, more space there, minus 1y equals 4x squared. I'm going to take that integrating factor, I'm going to multiply all three. Boom, times boom, and boom. All three. Okay, so step four. What do we do in step four? Step four says now the left side is the derivative of the product of the mu of x and the y, the integrating factor in y. Write it as such, right? ddx of the integrating factor times y. Oh, okay. So I'm going to say the left side is ddx of what? Of y and the integrating factor. What was the integrating factor? It was e to the minus x right here, right? And that's going to equal, on the right side, nothing's changed yet. Okay, so now you can double check. You don't have to, but is the derivative of this stuff really go back? It does. Remember this, these are two things multiplied. So product real derivative of the first, y prime, times the second unchanged, plus the first unchanged times derivative of the second. What's the derivative of e to the minus x? E to the minus x times negative 1 because of the chain rule on that, and that's where the minus 1 comes from. It's right. Okay, and then step five, integrate both sides of the differential equation. So then on step five, I'm going to come in with a big old integral, integral of both sides, t dx. Like that, right? Okay. Now, one side's easy, one side's hard. This side's going to just cancel right out because an integral and a derivative are opposites. They're gonzo. So that's really nice. That just brings down y e to the minus x. No, don't got to do anything. They just cancel out. That's why we do it. That's why we write a derivative on the left side because then we integrate it and boom, it's gone. Now on the right side, the integral, we're going to have to do the integral because it doesn't cancel out. There's not a derivative. It cancels out the integral. So we have to actually do this integral. How do we do that? Well, it's going to be by parts. And I'm going to show you a shortcut for by parts. Here it is. Here's the notes. Here's the old, the formal way of doing by parts right there. But if you go down a little bit in the notes, here's a shortcut method for integration by parts called the tabular integration using a table. And what you do is you just take the first part, the x squared, put it on the left, take the e to the x or whatever, put it on the right, and then just on the left side, the d stands for derivative. Just go derivative of x squared is 2x, derivative of that is 2, derivative of that is 0. Just keep going down until you get to 0. On the right side, take that e to the x and integrate, integrate, integrate. So derivative on the left, integral on the right, and then draw these diagonal lines when you're done and put plus, minus, plus, and you got your by parts shortcut integration. Let me show you. So I'm going to grab that. Um, 4x squared there, and then e to the minus x there. And then what am I going to do? Derivative, second of 8x, right? And derivative again. It's just 8 because that one power just comes down. And derivative again, 0. Just keep going down until you get 0. Now the other side, you can do the integral. What's that going to be? Minus e to the minus x, right? You can double check because you took the derivative of that. It'd go times minus 1. That would cancel this minus. You'd go back to plus, huh? Okay, and then do another integral. What's that going to be? I think it's just e to the minus x, right? Because if you took the derivative, you go times -1, it would go back, right? And then just do the integral one more time. And that would be minus again. It just switches back and forth, doesn't it? Plus, minus, plus, minus. Because you took the derivative here, this would go times -1. That negative cancels that negative. It would go back to positive, wouldn't it? All right. So what? Now, what about this? Now we connect these. We start with the first one, and we go diagonal, and we put a plus. Now we go diagonal. We put a minus on that one. We go diagonal, put a plus. Oops, this be a circle. Like that. That's our by parts integral to shortcuts quicker. So we got y times e to the minus x equals what? Well, 4x squared times negative e to the minus x. So minus 4x squared e to the minus x. And there's a plus on that, but we've already got a, plus and a minus, so it's negative. Next one is going to be negatives minus 8x times e to the minus x. And the last one, plus 8 times e to the minus x. So plus times a minus, that'll actually be a minus 8 e to the minus x. Oh, and don't forget your constant. I'm going to forget my, when you do an integral, you got a plus c constant, right? So now let me bring this down one more time. We're trying to get y alone. A little bit of room here. So be careful with your sign. So again, did you see that? That by parts tabular format. I just took the 4x squared and went derivative, derivative, derivative till it was 0. Took the e to the minus x, went integral, integral, integral. Be careful with the signs. And then diagonal, 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 plus, minus, plus, and count all the signs carefully. Positive times negative. That was negative. Negative times positive, negative. And positive times negative, negative, right? And then the plus the c. Be careful. And minus x minus 8x e to the minus x minus 8 e to the minus x. I wanted to get more room. I didn't do that at all. Plus constant. Okay, now what am we going to do? I got to get y alone. So I'm going to multiply by e to the positive x or regular x. Because those powers will add, e to the 0 is 1, so y is alone. Whatever you do to one part, multiply by e to the x, e to the x, e to the x, e to the x. Bring it down here. What do we get? Y equals. These are going to, powers will add. E to the 0 is 1. That's gone. Minus 4x squared. Same thing here. Gone. E to the 0 is 1. Minus 8x. Same thing here. E to the 0 is gone. Minus 8. Plus the constant times, whoops, times e to the x. Okay. So there's the function. But last thing is we've got to now plug in. Now, plug in what? Plug in what they told us to plug in, which is this. Y of 0 is 20. So that's my x. So put a 0, 0, 0, and y will be 20. So we say, oh, okay, so 20 equals, and that's just 0 minus 0 minus 8 plus c times 1, right? Because e to the 0 power is 1. So then just add that 8. Boom. 28 is C. C times 1 is just C. So C is 28. Okay. So that means this C right here is 28. So we have our final answer. Here it is. Y equals minus 4x squared minus 8x minus 8 plus C, which is 28 e to the x. There we go. There's our equation. Let's go check it. Minus 4 squared minus 8x minus 8. Um, minus 4 squared minus 8x minus 8. And that'd be 28 e to the x. 28 e to the x. Yep. That's minus 4 squared, right? Right. It is. It's all correct. They just wrote it a different way. There it is. And we've done it.